How's it going, you guys? In this video, I'm going to be talking about solving cube roots. So these are similar to kind of like square roots, except just remember that a cube root of a number is like the cube root of 8 is 2 because 2 to the third is 8. So we're just going to be seeing what kind of solutions, what kind of numbers can make these equations true. So it's going to be, like I said, same sort of idea as solving square roots, except just tiny tad different. There are no non-solution answers because cube roots can be negative, so even when we get down to this one, that we have a negative solution for a cube root, that is possible. Because remember, a negative times itself 3 times. So like what I'm talking about is a negative 2 times a negative 2 times a negative 2. That is still negative 8. So we can multiply a number 3 times to get a negative number, so that will be okay there. That'll be possible. All right, zoom in just poco more. That was zooming out. Wrong computer. Wrong computer. Okay. So with this one, still the very first thing we're going to want to do is try to isolate the cube root by itself. So that way I can cube both sides. So what I'm going to do first is get anything away from the cube root such that I just have the cube root on one side by itself. So here all I had to do is subtract 7 from both sides, such that now, in order to get rid of this cube root, I can cube that side and cube that side. So what that creates is that when I cube the cube root, it gets rid of the cube root. So I'm left with 2x equals 4 to the cubed is 64. And then last step there is usually pretty easy for you guys. Just make sure you divide everything by 2. So by 2, x equals 32 should be our solution. Cool beans. All right, moving on. Same sort of idea. So again, isolate the cube root. Here, notice everything on the left-hand side is in the cube root already. So that cube root is isolated. So I can go ahead and cube both sides. So cube and cube, such that I come out with 5 plus 8x. When I essentially cube the cube root, it gets rid of it. Negative 3 to the third is negative 27. Make sure you guys are careful about positives and negatives in here. So then it's just solving for x. So I want to subtract 5, 8x equals negative 32. And then divide both sides by 8. So divide by 8, and x equals negative 5. Happy day. All right, looking at another. So again, your first goal, make sure that you isolate the cube root by itself, so that way you can cube both sides. So in order to do that in this one, I need to subtract 3, such that that makes 0, and I'm left with 3 cube root of x equals 12. I know it's annoying, but make sure you guys take the time to write that little cube root right there. It means a big difference if it's not there. Then keep isolating that cube root. So divide by 3. So we have the cube root of x equals 4. Again, to get rid of that cube root, take the cube of both sides. So x equals 64. Happy day. You guys doing good. So again, isolate the cube root. I can't tell you enough. That's your first step in every single problem that you have with these. Get the cube root by itself, so plus 2. So that makes 0, so we're left with cube root of 6 minus 3x equals 2. Get rid of the cube root, take the cube, the inverse operation. 6 minus 3x equals 8. And then I'll need to subtract the 6. So minus 6. I have negative 3x equals 2. It's going to come out a fraction, but it's okay. Fractions are real numbers too. They have feelings. They have feelings like everybody else. So we would come out with x equals negative 2/3. That's all I'm looking for there. As always, please remember, you guys can pause, rewind, rewatch, whatever you need to do. But make sure you guys write these down as well. The more you write them down, I promise the more they will go into your brain, the better you'll do, the better you'll feel. And then you'll be like a giant because you grew because you ate your veggies when you were in math. I don't know. I tried. Come on, computer, focus. All right, and the next one, they're going to be a little bit different. But if you think back to that last unit, if we have something to the 2/3, what this means is we have the cube root of x plus 5 to the second power. So we could cube both sides to get rid of this fractional exponent, but something else that we could do to make our life a lot easier is if we actually multiply, well, sorry, take to the exponent, the inverse, the reciprocal exponent. So notice that's 2 over 3. If I take to the 3 over 2 exponent on both sides, what that does is up here in this exponent, 2 divided by 2 is 1, 3 divided by 3 is 1. So on this side, I am left with x plus 5. So again, I'm taking the reciprocal exponent, so I'm flipping the fraction in the exponent, so that 2 over 3 becomes 3 over 2, so that 3 divided by 3 makes 1, and 2 divided by 2 makes 1, so that I just have x plus 5 to the first power. Now on this other side, we're taking 4 to the 3 halves. So here, you have to be careful. This number right here, remember that means what root we're taking? This 2 right here, that means what root we are taking. So this is taking the square root of 4 to the third power. So now, notice we took the square root. And remember, back when you were doing this stuff, when you're solving square roots, anytime you took the square root, we put a plus or minus. So in front of this fractional exponent 4 to the 3 over 2, if this is an even number down there, you need to do the plus or minus. I'll rewrite 4 as 2 to the second to the 3 halves. So again, anytime you're taking a square root, a fourth root, a sixth root, any even number root, make sure you put a plus or minus in there. It will change our answers because we don't know whether the positives multiplied or the negatives multiplied to be that number. So now that I've rewritten this 2 squared, 2 divided by 2 makes 1. So now I'm left with 2 to the third. So this is x plus 5 equals plus or minus 2 to the third, which is 8. So now I need to subtract the 5, so I'll have 2 possible solutions. Negative 5 plus 8, or x equals negative 5 minus 8. Those are both possible answers because I have that plus or minus in there. So it could be x equals 3, or it could be x equals negative 13. Those are your 2 solutions for that. So again, what you're looking for, multiply by the reciprocal exponent. If the denominator is a square root, a fourth root, so an even number down there, make sure you put the plus or minus in front, simplify your number inside, reduce your exponents, and solve for your number. All right, we're going to do another one. Don't fret, that's not the only one we're doing. So same idea. Notice we have x plus 2 to the 2/3. Again, this is a cube root because I'm taking the denominator's root, so the cube root, the third root of x plus 2 squared. You don't have to rewrite it like we did in that last one though, because we know in order to get rid of that fractional exponent, I'm going to multiply, well not, sorry, I keep saying that. It's not multiplying, it's taking the reciprocal exponent. So that now, 3 divided by 3 makes 1, 2 divided by 2 makes 1, and notice I'm taking a square root, so I need to write a plus or minus in front of whatever number I get there. 9 is 3 squared. I still have that 3 halves. And this side just becomes x plus 2. So 2 divided by 2 makes 1. So I'm left with 3 to the third, which is 27. So this is now x plus 2 equals plus or minus 27. And then subtract that 2 over. So I have minus 2. So it could be negative 2 plus 27. It could also be negative 2 minus 27. With that plus or minus, that makes all the difference in the world. So we have x equals 25 and x equals negative 29. All right, got a few more for you guys. Make sure you're good and solid on this. So notice here, just like in our last ones, we need to isolate our whatever root we are taking. So here we're taking the cube root of x minus 2 to the fourth, but I need to get that by itself before I take the reciprocal exponent on both sides. So what I want to do first is subtract 3 and subtract 3, so that I have 3 times x minus 2 to the 4/3 equals 243. And then I'm going to divide everything by 3 because that 3 is on the outside multiplying. So divided by 3, divided by 3. So So I have x minus 2 to the 4/3 equals 81. And then notice we have that 4/3, so I'm going to take the reciprocal exponent on both sides. So 3/4 and 3/4. And notice I'm taking the fourth root of something. So again, an even number root needs that plus or minus. 81 I can rewrite as 3 to the 4th to the 3/4, and then this side is just x minus 2 now, since 4 divided by 4 makes 1 and 3 divided by 3 makes 1. So, and note, rewriting the number inside, it's always useful if we can get it the same number as the denominator here, so that those divide out, because 4 divided by 4 is 1. Notice in the last one, we rewrote 9 as 3 to the 2nd so that our denominators would divide out. We rewrote 4 as 2 to the 2nd so our denominators would divide out. If you can make those denominators divide out in the exponent, do it. Do it. Do it, yo. Alright, so we're left with x minus 2 plus or minus 3 to the 3rd. Those divided out, so 3 to the 3rd is 27. So I have x equals 2, because I need to add that over, so plus 2 plus 27, and x equals 2 minus 27. Two possible solutions. So I have 29, and I have negative 25. If you want to write it like that, save a little bit of time, that's fine too. Alright, doing good. So with this one, same idea. I need to get that junk all to the 4/3 by itself. So I need to add 3 first. So that I have 2x plus 3 to the 4/3 equals 16. And then take the reciprocal exponent on both sides. So 3/4 and 3/4. So I have 2x plus 3 equals plus or minus, because I'm taking an even number root. Even number root means I need that plus or minus. I can rewrite 16 to the exponent of 4 by using that as 2 to the 4th. And then I have to the 3/4. 4 divided by 4 makes 1. So now I'm left with 2x plus 3 equals plus or minus 2 to the 3rd, which is 8. So if you want to break it up into two equations here, it might be a good idea, because we have essentially 2x plus 3 equals 8, or 2x plus 3 equals negative 8. Those are both good solutions. So that way, instead of thinking about the plus or minus all the way through the equation, you can just do the math as you see it. So we have minus 3, minus 3, minus 3, minus 3. So on this one, I have 2x equals 5 divided by 2, x equals 5/2. I'm off the screen. All right, and then minus 3 there, so 2x equals negative 11 divided by 2, x equals negative 11/2. Fractions are fine, they're still people. They have real feelings. Don't hurt their feelings. All right, so biggest thing I can help you guys with, if you see this fractional exponent, make sure you multiply, or keep saying it. Make sure you take the reciprocal exponent on both sides. So if I had 4 to the 3rd, or 4/3, then I need 3/4 on both sides. If I have a positive number, even number, I keep saying the wrong thing, even number exponent, I need to do a plus or minus in front of our number. So let's look at one more. So I just want to reinforce those ideas. So again, I have 2x to the 1/3. That is the thing I want to get by itself. So I need to move this 1. I need to subtract 1 from both sides, so that I have 2 times 2x to the 1/3 equals 4. Still, I need to get that by itself, because that is the only thing being raised to the exponent. So I need to divide both sides by 2 to get rid of the 2 in front, because that was multiplying it. So I have 2x to the 1/3 equals 2. Now to get rid of this fractional exponent, I need to take the reciprocal exponent on both sides. So if I take 3/1 and 3/1, now notice, this is just cubing something, right? 3 over 1. I'm taking the 1th root, even if it was a 3 or a 5 or a 7 or a 9, whatever. If that's an odd number root, I don't need to rewrite that plus or minus. And this is just 2 to the 3rd, so that's just 8. That's just 2x because 3 divided by 3 and 1 divided by 1 make 1. So this one, all I need to do is divide by 2 and x equals 4. So notice, I did not add the plus or minus because I am taking an odd number root. It's the 1st root, the 3rd root, the 5th root. So like I was saying in all of these, if I take an even number root, then I need the plus or minus. If I take an odd number root, I do not need that plus or minus because odds can multiply to be negatives. A number times itself an odd number of times, like I was talking about, because I'm multiplying negative 2 by itself 3 times, an odd number of times. That came out to be a negative number. If we had an even number in there, I don't know whether I'm multiplying negative 2 4 times to be positive 8, or if I'm multiplying 2 4 times to be positive 8. So we have to include both solutions. That's why we do the positive or negative. All right, hopefully this video was helpful for you guys. I will see you soon. Love you guys. Bye-bye.